Our guest speaker tonight is Chris Mattia, W6AH, and he hasn't been an amateur for very long, but he's crammed a whole lifetime in what he's done. He got his ham license as the result of the Thomas Fire ripping through his hometown of Ventura, California, and decided he needed to do something. So over the next 8 months, he got his license and he began operating with ARES in the LAX area in both the Northwest and the Northeast districts. He upgraded to general and started regularly operating on HF and experimenting with digital communications, antenna building, and portable operations. 9 months to the day after the Thomas Fire broke out in Los Angeles and Ventura counties, he passed his amateur extra exam. And as a teacher with professional video training, he looked for ways to help other amateurs obtain or upgrade their license. So he became a VE with both the W5YI group and the ARRL. And he began helping to teach classes with various groups and created a website called wavetalkers.com. And he'll probably comment about what that is. But he now operates with both the Ventura ARES and the LAX chapter of ARES in the Northeast District. So, and he's a fellow sailor. So I'm going to go ahead and hand it over to Chris and say, thank you, Chris. We welcome you tonight.
Great. Thank you very much. Let me go ahead and pin myself up so that everybody's going to be able to see me. Can you all hear me well enough?
Yes.
Good. So I'm going to hit spotlight. And there we go. And then I'll do, let's see if I can do a little magic trick here. Boop, there we go. There are the slides that are going to come in behind me. And I will just maybe transmogrify myself down into the corner. That'll make it a little bit easier to see what we're doing here. So what I'm going to talk about tonight, thank you, by the way, for such an amazing introduction. As you mentioned, I set up the Wave Talkers website in order to help amateurs get their license and upgrade. I've been a professional teacher and been involved in higher education for more than 25 years. And I do video production for teaching and learning. So I figured, well, let me just bring all of that experience into this realm. So as part of the setup for this overall talk, I have reached out to a bunch of different vendors. And so there are many products that appear in this overall talk that were sent to me by vendors, although they have no influence over anything that I say or anything like that. But I got them all so I can help teach this stuff to amateurs because I don't have the funds to be able to buy all this stuff myself. And many of these companies have been gracious enough to help me out with that. So with that, what I'm going to actually talk about tonight is solar and emergency power for emergency communications. And we're really going to focus in on the emergency communications aspect to it. So I operate with, if we can have everybody also mute yourselves if you're not muted. I operate with both the Ventura ARES ACS group as well as the Los Angeles ARES group, both in the Northeast and in the Northwest district. So I kind of operate wherever I'm at to help out. And in 2019, I helped provide support for the Baker2Vegas race, and I was part of the medical radio network, or the MRN, and I took care of a couple of the stages. And so what we're going to talk about today is what happened during that race and how we problem solved for it in terms of solar and emergency power. So with that, let's see if I click this mouse, there we go. All right, so at each of the different stages along the race, there's a medic station that's set up. So the race runs from one stage to the next. And I was responsible for several of the stages, 6, 7, and 8. And at stage 7, at all the stages, we had to deploy these what are called MRKs, or medical radio kits. It's a commercial Harris radio. It's all fully self-contained. It's got an antenna that's a mag mount, pops up on the medic's car. It's got a speaker. It's got the radio, and it's got a long power cable that is supposed to plug into the auxiliary port on the medic's vehicle. Well, at stage 7, the medic's vehicle didn't actually have a 12-volt socket. So we were not able to plug in to their vehicle. So we needed another solution. And that's what we're going to talk about tonight, is how do we deal with that and what did we do? So I got to move which mouse I'm clicking on so I don't keep clicking with that mouse. All right. So the first thing you do when you come into a situation is you assess the situation. You identify the needs, you prioritize them, and you come up with some resolutions that, whatever you can do. So the first thing that we needed to do, we had an immediate need for emergency power because we had to get the MRK on the air right away so that the medic could check in. And when I say check in, the Baker2Vegas race takes place over 150 miles of desert. And so it's from Baker all the way out, Baker, California, all the way to Las Vegas, Nevada. And we were backhauling all of our radio communications back to Las Vegas dispatch. So we had to traverse 150 miles of desert to do this. So we had to get the medic on the air so they could check in. The next thing we had to do was we had to sustain the power in that radio so that that station could operate for at least 15 hours. And that was based on how far we were into the race course and about what we estimated that the last runner would pass our area and we would be able to shut down for the evening. So we knew we were going to need to keep on the air for about 15 hours. And so let's come up with a solution. So here's that auxiliary plug. It's pointed out right here on the radio. And so what were the options for getting this on the air? So the first option is, well, let's take the easy way out. Let's just move another vehicle in and plug that 12-volt socket in and just use that and get them on the air. Would work great, except for at the time we were getting started, there were no other vehicles available that could stay in that location all day long. So it wasn't an option for us. Next option, use some kind of a generator, AC inverter, convert it to 12-volt DC using an aux plug, get that out. Another great option, except for I didn't have a generator with me. I was a fairly new ham, and so I didn't have quite the kit that I have available with me right now. So that leaves us with a third option of, okay, let's use a battery and let's power this thing off of a battery. Well, I did have a battery with me. And so let's talk about battery technology. And I'm going to talk in very, very general terms. So we're not going to go into a huge amount of detail here on this, but I'm going to take the entire world of batteries and I'm going to divide them right down in the middle. And I'm going to call some of those batteries traditional batteries. I'm going to call some of those batteries modern batteries. Now, the traditional batteries that we're going to talk about, these are your lead acid flooded batteries. Here, let me go ahead and move myself out of the way so you can see there's a picture of the 12-volt lead acid battery in the back of my Mini Cooper. All right, 12-volt lead acid. Next one would be AGM, or absorbed glass mat, AGM batteries. And along with those are also gel cells. These are very common deep cycle batteries you find in the marine industry. And as was mentioned, yes, I lived on a boat for many years, and so I'm quite familiar with deep cycle batteries. Let's move over to the modern side now. The modern side, I'm going to talk about just two basic types. There's lots of them out there. We're going to talk about lithium ion, and we'll talk about lithium iron phosphate batteries. There are a few other new modern battery technologies, but these are the two that we're going to divide the world into for tonight's purpose. So let's talk about some of the advantages and disadvantages of your traditional 12-volt batteries. First, high capacity. You can get a 12-volt, like a car battery or a deep cycle battery, in a very large capacity in order to keep your radio station on the air for a long amount of time. These are relatively inexpensive. Price per amp hour is pretty low. They're very common. You can get them all over the place. They're readily available. Pretty much anywhere you go, you can find one of these things. Big box store, hardware stores, auto parts stores, you name it. They're pretty much everywhere. You can get deep cycle models available. Now, if you're not familiar, deep cycles and the starter batteries that you have in your car are two very different technologies. Starter batteries really thin lead plates. They put out a lot of cranking amps in order to get your vehicle started, whereas a deep cycle battery will typically have very thick, heavy lead plates inside of them that will resist breaking down, and you can pull a lot more, you can pull their charge down a lot lower. If you're doing amateur radio, it's a really good idea to use deep cycle batteries because you want to be able to if you're able to pull that charge down and get more power out of them. They're just better designed for that. Disadvantage side, these things are extremely heavy. In fact, I like to call them lead mines because they're way too heavy to actually carry around. Most people that you see when they're using traditional lead acid batteries, they also go down to the hardware store and they get themselves a hand truck and they strap the batteries to a hand truck so they can move them around. It's not a very portable solution for amateur radio. As a backup in your house, not a bad solution, but definitely very heavy. And another disadvantage that we're going to talk about in just a few minutes is the discharge curve, and we'll explain that in just a minute. In the meantime, let's go over and flip to the other side, which is the modern 12-volt batteries. Again, extremely simplified. So lithium ion, this is the battery that's in the back of your HT for the most part, pretty much. And they ship HTs with a few other different technologies, but for the most part, most modern HTs are shipping with a lithium ion battery. We're not talking about those tonight. What we are going to talk about are the lithium iron phosphate batteries. You'll also hear me refer to these as LFP or LiFePO4. And if you remember back to your high school chemistry class, that is lithium for LiFe is iron, and PO4 is the phosphate group. So it's a little bit modified battery technology by adding that iron in there, which makes them a lot more stable. They don't blow up. They've got some great other properties with them as well. So that's what we're talking about right there. So let's talk about their advantages. Whoops. Let's go back. Advantages. They are extremely, we're back to, I went back too far. Sorry about that. Pushed the buttons too many times. I got a lot of buttons here. Modern 12 volts, there's the lithium ion, and forward one, there we go. Extremely high energy density. So with high energy density, you can pack a lot of charge inside of the physical size of these batteries, which is amazing if you're needing to operate portable, which we do a lot with EmComm. They are light and compact for their size, for their energy density. These are remarkably light, in the order of say a 20 amp hour lead acid battery might weigh in the neighborhood of like 24 to 25 pounds, whereas a lithium iron phosphate battery that's in the 20 amp hour range is going to weigh closer to 6 pounds. So a huge difference. And if you're going to be carrying these things, I'm going to want to carry a lithium iron phosphate battery as opposed to a lead acid battery. High number of charge cycles. Now, this is one we don't really think about a whole lot, and that is when you charge a battery and you discharge a battery, it takes a little bit of a hit on the battery itself. And we've all used like disposable rechargeable batteries, and they last for a good little while, but the charge kind of wears on them. All your HT batteries over time, the number of charge cycles goes down, and you got to get a new one. Lithium iron phosphate technology is such that you get a very high number of charge cycles. Around 2,000 is common, which is great because that really extends the life of your battery. The next is the nearly flat discharge curve. I'll just roll out of the way for a little bit for that one. Nearly flat discharge curve. Again, we're going to come back to discharge curve. Let me try that again. Discharge curve. We're going to do that in just a second. And the last thing here on their advantages, the connectors on these batteries are suitable for EmComm, meaning most of your lithium iron phosphate batteries that you're going to just order as far as the ones that you're going to do for ham radio, emergency communications, they already have power poles on them, which means they're going to integrate with all of your gear. And we'll talk about power poles a little bit more in just a few minutes, but that's a huge thing. It's so easy to just take one of these batteries. I've got one here, and they've already got the connectors right there on them to be able to plug in. I mean, it's fantastic. Disadvantages, high initial cost. Now, this is one that's a little hard to swallow for all of us, because when you go and you look at a 30 amp hour battery and it's like $200 and some dollars or $300 or whatever they're going for these days, you find out that these things are actually pretty expensive. But when you start taking into account the number of charge cycles and really the discharge curve and the weight of them, suddenly they're not quite such a bad deal after all. And we'll talk about that a little bit more. So here's this discharge curve thing that we're going to talk about. So what we've got here is over the life of when you're using your battery, it starts, actually, I got to move my hand this way. I always forget it's always backwards. So on the vertical column here, this is the voltage of the battery. Now, living on a sailboat, I could always tell when my house batteries were low because the lights would start to dim down really shallow. And I went, oh, it's time to turn the charger back on, because the voltage had continued to drop. And it drops on a lead acid battery. Let me move this mouse over here like this. It drops on a lead acid battery in a pretty much linear curve. So they generally start somewhere around 13 volts or so, and it just steadily drops off the voltage that's there. With a lithium iron phosphate battery technology, what happens is it's got this flat discharge curve. So for a long time, the slope of this line is really, really shallow, and then it drops off precipitously at the end. Now, why does that matter to amateur radio operators? Well, it matters because of this gray line right here. So I've got this plugged in here at roughly 12 volts. Every one of your radios that you're going to operate with, especially on the HF side or any of the bigger mobile rigs, they require a certain amount of power, and they all vary. You know, some are, they require at least 11.5 volts, some require 12, some require a little bit more. It varies from radio to radio. So we're going to simplify this down, and we're going to say 12 volts is the cutoff. And so that means if you're using a lead acid battery, once the curve cuts below that line, you're done. Your radio turns off. And even though there's more charge in the battery, there's all this charge over here in the battery, you can't use it. It's not usable to you because it's delivering a voltage that's lower than what your radio needs. Now, there are voltage adjusters that you can put on there, and you can artificially boost up the voltage. You can squeeze a little bit more out, but you can't squeeze a whole lot out. When you compare that, so roughly on a lead acid battery, you're going to get somewhere in the neighborhood of like 45 to maybe in the neighborhood of 55, most maybe about 60% of the charge that's stored in that battery out. So in simple terms, if you've got a 100 amp hour battery, you're only going to get 40 to 50 amp hours out of that battery. The rest of it, not usable to you. Now you're carrying around all that weight. Now, if you switch over to the lithium iron phosphate batteries with that flat discharge curve, suddenly you're getting somewhere in the neighborhood of 90+% of the power that's stored inside of that battery back out of it, which means you can use a little bit smaller battery and get more life out of it. That's really important, especially for EmComm. And so that tells us that if you're going to be building yourself a go box, if you're going to be building yourself some kind of an amateur radio that you're going to take out into the field, if you're still looking to choose a battery technology, choose a lithium iron phosphate one. There's lots of them on the market that you can choose from. I happen to use the Bioenno batteries, and yes, they do send me these. This is the 30 amp hour battery that I use. It's in my go box, and this is where I've got my Kenwood D710G, and then it's all wired up for being able to get power out, and it also works as a solar charge controller and all those fun things. So, but if you're gonna choose a battery technology to put in a new setup, I would go with lithium iron phosphate. Okay, so how do we make the connection now? We got our battery. What are we gonna do with it? Well, I like to say power pole everything. Every bit of electronics that you have related to your ham radio, anything that's going to run off of DC power, put a power pole on that sucker. And what I mean by doing this, all right, when I have my kit that I carry out in the field with me, I have a bag, looks something like this. Oh, it's green, so it's not really, you can't really see a whole lot of it. Sorry about that. I forgot that it's green, and I've got, anyway. So what you want to do is put a power pole connector on all of your adapters. So whenever I get a new piece of kit, one of the first things I do is I take my nippers and I just clip the the power connector off of it, and I crimp on a set of power poles. So let's run through just a couple of these. So this is a big set of little alligator clips that are here and power pole connector on the other end. So I can use these if I've, if there's a vehicle nearby and there happens to be a battery inside and I need to tap into it, pop the hood, clip onto it. I got power poles out the side of it. This is power poles to ring connectors. I use this oftentimes with my power inverter because it's got terminal posts on there, so I can just attach those over. Boom, I've got AC power directly off of whatever my battery source is. I always keep a power pole connector that's crimped up, ready to go, but has nothing on the other end. It's just got bare wires. So when I'm in the field and I suddenly realize, hey, I need to adapt to some other thing, I don't have to go out and get my crimper. I can just attach whatever that adapter is just directly onto the power pole wire that I've already got, and I've saved myself a bunch of time. This is for my solar panels. One of the set of solar panels I have has this custom connector, so I clip the end of that thing off and put a power pole connector on it. I made a little Y adapter. So here I've got one power pole connector on this end, and I took two wires, two red, two black, crimped them together, and then have a set of power poles off the other end. So I'm able to very quickly just divide out my power. If I need to run two different devices, suddenly I can do that with one cable. Here I picked up a 12-volt plug and a 12-volt socket set. You get these on Amazon for like $2.50, $3, something like that. Take the back of them off, unsolder the terminals, solder on your own wires, crimp on power poles, and you just saved yourself about $40 from going and buying those custom ones that are already made. And because you've got your crimper, you just go ahead and do that. I use an EmComm 7300. I took the back of that wire, clipped the end of it off, crimped on a set of power poles. Just after that, your radio connector port, you oftentimes have, and you should have, fuses, inline fuses. So I clip the fuses off of the main line when I get it and put power pole connectors on it. Now I've got adapters for each of my different radios that I have, and then I just have these little pigtails that have inline fuses. So you can adapt an inline fuse at any point in where you need it. It's really simple to do. This is a rig runner. This is great because you plug one power pole connector into one of these and then it distributes, and so you get additional ports if you got multiple gear you need to run. This is just a long extension cable. It serves two purposes. First, it connects from my solar panels out to wherever my radio needs to be or my solar charge controller. But the other thing is, I've got a great big long extension cord that I can use to run a longer length, or maybe I need to chop it up into smaller bits while I'm out in the field and use it. All that's great. Here's one that's got just little small alligator clips, a 12-volt socket, a 12-volt plug connector. That's a USB charger. So I can bring the cables for my cell phone, for my tablet, for whatever I need, and I can plug USB directly into my Go box. I also keep a set of power pole to barrel and barrel socket connectors in there because there's lots of different devices that suddenly you just need to plug in and go. So this is what I carry around with me on a regular basis, and it changes depending on the specific needs, but this is kind of the basic kit that goes with me all the time. Next is crimpers. This is great because you can get a good set of crimpers, make your investment in the tool, get yourself real power pole connectors. Don't buy the cheap ones because they don't always kind of work very well. Yes, the power pole connectors are expensive. They're generally about $1 a piece by the time you get them in, but you build out your kit and it's really flexible. And if you do any kind of Aries work at all, everybody in Aries uses this system. So you show up to field day, you show up to any kind of activation, whatever, all of your gear is interoperable with everyone else's gear. Way important thing to go. If you do not know how to crimp your own power poles, there's great videos on the YouTubes. Find somebody else in the club who knows how to do them. If you can't find anybody else, give me a call. I'd be happy to help you learn how to crimp these on. It's a great skill to pick up. Okay, back to our story. So we found our battery. We got the connector that we need. We were able to make all of the adapters so we can get to a 12-volt socket connector. We got that MRK radio on the air. The medic is able to check in, and all of that took about 5 minutes to do because I just had a spare battery there with me. I put it down. I plugged in the 12-volt socket connector out of the adapter kit, plug the radio into that. Bob's your uncle. We're done. Medic's on the air. Next thing we need to do is answer the question of how long will it run? And that is a question of amp hours. I really want to encourage you to start thinking of your power for amateur radio in terms of amp hours. And that's for a couple of reasons. One is it's way simple. It's really easy. You have how many amps will the machine draw over the course of an hour. And most of your batteries also tell you the number of amp hours that are inside of the battery. So it's kind of like your gas tank a little bit. It's a way easier way to think of it. And a lot of people, think of these in terms of watts, but we have 5-watt radios, we have 100-watt radios, we change the wattage that we're using. That just starts getting confusing into all of these things because you're not talking about all of the same things. So let's talk about amp hours. So I made a little kind of thing so we can kind of work through this. So let's say we have a 30 amp hour battery. It looks something like this. So 7.5 pounds, not too bad. All right, 30 amp hour battery. Whoops, I keep doing this. I'm going to go back to just clicking on the buttons. And our radio draws 1 amp. How long can that radio operate on that battery? Well, in a very general sense, we take 30 amps, we divide it by 30 amp hours, we divide it by 1, and we get 30 hours. Pretty straightforward, pretty easy math to do. Let's do another little example here. So 30 amp hours, let's say our radio draws 2 amps. How long can it run? 30 divided by 2, 15 hours is about what that radio can run. It's going to vary a little bit, but that's a good kind of gauge for you. Let's do one more of these. 30 amp hours. How about if your radio is drawing 10 amps? Well, you're only going to be able to run that radio for about 3 hours at that current draw. And through all of these examples, I've been talking about your radio, but really it's whatever your load is. So let's say you're running a couple of other devices off of your radio. You need to add all of those devices up, the current draw that they have. So if you take your radio and you look on the back of it, oftentimes it'll say it requires, draws so many amps or so forth. So let's look at how you determine that. We're going to look at 2 ways to determine the current draw for your radio. And the first is to break out the manual. So this is a little section of the manual for my Kenwood D710G that I have and I operate with. And you'll notice that on this setup here, over on this side, we have the transmission range. So high, medium, and low. This is how much at VHF or UHF current your radio is going to draw. So on low power, you're only going to draw roughly about 4 amps on the VHF side. And on UHF side, it's going to draw a little more. It's going to draw about 5 amps on transmit on low power. Mid power, so that's roughly on this radio about 5 watts. On mid power, it's 20 or 25 watts, I think. It's still going to draw about 4 amps, 6.5 amps on the UHF side. But look at this. We jump up to high power, which is 50 watts. We're drawing 13 amps out of the battery for both of these on that radio. So that's a real big lesson right there. One of the ways that you can lengthen out the time that you're able to operate is reduce the amount of power. You remember back to when you took your technician license, one of the questions in there was you're supposed to, as an amateur, just use the minimum amount of power necessary to get the communication done. And this is a really good example. If you crank that power up, your battery is not going to last as long. The other piece that's really key is this last line here, and that's current drain on receive. And on my Kenwood, it's going to draw about 1.2 amps all the time when it's listening. So if I've got the radio on, it's drawing 1.2 amps out of the radio. As a little aside, if you're operating HF and you've got a QRP radio, set that QRP radio to be your monitoring radio because its power draw is way less. It barely draws any power, it just sips power. And then you can use a higher power radio or an amp to be able to boost the power up, and then you're managing your battery power a lot more effectively and a lot more efficiently. So keep these numbers in mind. You can look up in your manual and you get a pretty good idea of how much power your radio is drawing. So the other way is to get a little device. So this is by PowerWorks. You can pick them up in a lot of different places. You can get them on Amazon and so forth. Really simple meter. On one side over here, you plug in the source, which in this case, in many cases, you would plug the battery onto the source side because that's where the power is being drawn from. And on the other side, the load side, you would connect up your radio. And then it's got this little display and it just cycles through a whole bunch of settings. And it tells you how many amp hours of power, how many amps that your radio is currently drawing. So right now, this one is drawing 0.15 amps and it's moved a total of 5.206 amp hours. So 0.15 amps is, it's actually just charging here right now. So, or it's finished charging. So those are the numbers that you would be looking for on something like this. Now, if you've got multiple devices plugged in, you would want to plug this in between your battery and all of your downstream devices. So you can find the total load on your battery. This is much more accurate than what is necessarily in the manual because it's really how you're using it. Okay, so in order to help figure all this stuff out, because I just threw a lot of numbers at you, I tried to simplify all of this stuff and I made a little calculator. So let's see if I can bring that up. Here we go. Oops, I was typing here. So I created this little simplified duty cycle calculator, and all it is really just a Google sheet in here that can run a couple of calculations. So we have our battery, we put in how many amp hours we've got, we put in our radio station on receive, the number of amps, and I have a cheat sheet right here. My Kenwood said 1.2, so I'm going to come up here and I'm going to type into this field. I'm going to say 1.2, and we'll come down to one more blank here, and what did I say? 13 amps, so we'll say, click into that field right there. Say 13 and enter, and magically, if we have 100% duty cycle, meaning we're transmitting all of the time, we're only going to get about 2.3 hours out of that battery. Whereas if we've got a duty cycle of 1%, we're going to get about 24 hours out of that battery. And then this just kind of calculates at a bunch of different ranges. So in general, as amateurs, we're supposed to be listening a lot more than we're speaking. And if you're in an EmComm situation, unless you're running as the net control operator where you're constantly transmitting, if you're net control, you're up in this range up here. If you're just an operator, you're more than likely down here, 10 to 25%. So my Kenwood, I've sized my battery for my radio. So I know I can pretty much get roughly in the neighborhood of about 20 hours of operation of my radio with my 30 amp hour battery. So that's pretty good way of doing this. However, the whole challenge here is because we're trying to do this MRK radio. So the MRK radio is a lot more power hungry, 4 amps on receive and 20 on transmit. So let's come up here and let's plug that number in here. So 4 amps on receive and 20 amps on transmit. And if we come down to the same range, we're in the 6 to 7 hours of operation. And remember, our goal is 15 hours. We've got to keep the station on the air, which says right away, it ain't gonna happen. We need another solution. Swing back over here. There's our simple duty calculator. And so there we go, roughly about 7 hours at a 10% duty cycle, which is on high. And we have to be on high. We can't reduce the power because if there's a medical emergency, we have to be able to transmit and get all the way back to dispatch. So that was our parameter. So we have a couple of options now. The first is we can reduce power if possible. Party said not possible there for that. We could add additional backup batteries. We could augment the power in some way. Now, this could be using a variety of different ideas. So one of which, in order to keep your station on the air, ideally, we would want to carry with us for doing EmComm work 2 to 3 days worth of all of our gear, including power. Well, that's not really feasible to be able to do, especially if you're using a lead mine, unless you've got a pickup truck to be able to haul those things around. You could generate enough power to augment your EmComm power. That's the goal. That's really the thing that you want to be able to do, where you're able to add just enough power to keep yourself on the air for an extended period of time. And that leaves you with a couple of options. You can use a fossil fuel generator. Those are great if you have them available, but you also then need to make sure that you're carting enough fuel with you. Now, we're all in the LA area. We're all concerned about the big one happening. And let's say we're doing support at one of the hospitals. The whole city is down, can't move anywhere. You're probably not going to be able to carry a generator with you and all the fuel that you need into the location in order to keep your radio up and running. So generally not a good idea. Solar, definitely a good idea. Wind, possible. Hydro, it's a drought. We don't have any water here in California. That's just not realistic for us at all. So solar it is. So let's talk about some of the common types of solar cells and solar panels that are appropriate for EmComm. And I'm not going to go into all of the ones that are out there. I'm going to break the world again. We're going to simplify things down into 3 basic ones. So the first one is the monocrystalline panel. Now, mono means one, crystalline is a crystal. And so the way that these panels are created, they grow this silicon wafer, and each of these squares that you see up here are generally one solid crystal. That makes them a lot more efficient. You can usually tell these solar panels because they look kind of black in appearance when you see them. They look as if each cell is one solid cell. And a lot of times, although it's not a dead giveaway because marketing has gotten involved with some of these companies, but the easy way to kind of tell at a glance is you see these big diamond patterns that are inside of the solar panels. That's a pretty good tip that it's generally one of the monocrystalline panels. These are the most efficient panels that you're going to find. You're going to get your biggest bang for your buck in terms of price, in terms of wattage that and amp hours that they're going to produce, or amps that they're going to produce out, and so forth. So great choice here. The next is your polycrystalline. Now, notice you've got this nice weird gradient that goes through them. Poly means multiple, crystals is crystal. So each one of those little squares would be created by a whole bunch of little tiny silicon wafers that have all been glued together essentially, which makes them a lot cheaper to manufacture because you don't have to grow the great big crystals. And so they're really much cheaper. So if you go down to Harbor Freight and you get that great deal on those panels that are there, they're more than likely going to be polycrystalline panels, which means they don't produce very much in the way of power. Even though they might be a 100-watt panel, they're going to be really big. So you've got to have a lot more surface area in order to generate the same amount of power. So we're talking about EmComm here. We're talking about having to carry a lot of our gear with us. You're not going to be carrying a lot of these polycrystalline panels. And more than likely, a lot of the monocrystallines, they come in a lot of different formats. And I'll show you a couple of different examples. But there's a lot of monocrystallines that are way too heavy. In fact, I have a set right here behind me. These are the big ones from Bio-Eno, and they weigh like, I don't know, 20 pounds or something. So I'm probably not going to go hiking with those anytime soon. So that leaves us with another option here, and that's a thin film. And oftentimes the thin film solar panels, they're brown in color. There are others out there, and there's actually not a whole lot of manufacturers of these right now, but they are less efficient in terms of power generation. So you need to have a much larger surface area of these, but what they lose in efficiency, they make up for in price because they're really expensive. And they also make up in terms of portability. So you saw that big monocrystalline panel I had there. That is a 60-watt solar panel. And you imagine trying to hike somewhere with that. This is a 60-watt thin film panel that completely folds up, and look, it's flexible, so it goes right in my go bag. It's ready to go with me. I just flip it out and it's ready to go at a moment's notice. Super easy. So those are the 3 different kind of types of panels that you're going to find out there. So here's a picture of my boat. And this is that monocrystalline panel that I just picked up. This one's by Bio-Eno. It's a 60-watt panel. You can see that kind of telltale big diamond shape on there that's connecting the different cells together. You can also see the sub cells that are on there. So these are all wired together in this kind of little grid, and then you go up another one, and those all wired together as well. So those are those. It does have an integrated aluminum frame into it, but they're really efficient. They're really nice panels. This next set of panels, also by Bio. These are also monocrystalline panels, although these ones fold up. These, there's 2 of them, and they're each 28 watts as opposed to the 60 watts. So the 2 together get you pretty close to 60 watt. The 60 watt panels, both of them put out about 4 amps of power. These put out a little less. These put out about 3.8 amps of power in full sun in Southern California in ideal conditions, when there's no fires and the sky is smoky and all of those kinds of things. And then this is that 60 watt panel. That's the thin film. Notice I just take this thing, throw it out anywhere, boom, it's on the air. It's really nice to be able to use. It's packable, and that is a huge difference there. As I showed you, this is what it looks like. This is my complete solar kit that I oftentimes take with me. So I've got a 12 amp hour battery. It's this battery that's right here. And I've got my solar charge controller. I use the Buddy Pole Power Mini. We'll be talking about those more in a little while. And the PowerFilm Solar 60 watt panels. Now, while I'm on this screen here, you can see the size of this battery. Now, if you're going to travel anywhere, and I know a lot of us are not really traveling right now, but there are restrictions by the FAA as to how much of a power of a battery, of a lithium battery, that you can take on an airplane with you. And the level that is anyone can take, you can take any of them, and they've got to go in your carry-on, is 100 watt hours. And you can see on the sticker that's on these, it tells you how many. So this is 144 watt hour. So you can take 100 watt hour across the board on any airplane. But there's an extra loophole in there that says, with approval from the airline, you can take up to 150 watt hour. So I fly Southwest. I take this one with me all the time. It's 144 watt hours. I've never had a problem going through. I carry it with me. If you go to Bioenno's website, they've got a little form you can print out that has the rules that the TSA wants to see. That's right there, all the documentation about it. So if there's any question, boom, it's right there. It's very easy. So this is a portable power that you can take on a plane with you if you want to go operate on a de-expedition somewhere. All right, so let's talk about solar panels and how they're actually wired. We're going to talk about series and parallel and the shading effect on panels. So what am I talking about here? So solar panels that are wired in series, and by I'm talking about the actual panels themselves, the little small squares, how they're wired together in the panel. So not something you're going to be wiring, the panels you're buying from the manufacturer. Panels that are wired in series add their volts together, so you can get the right amount of voltage that your solar charge controller will use and that your battery is going to use, and so forth. Most of the ones that you're going to use are going to be producing anywhere from 12 to 17, 20 volts in that, and then your solar charge controller will manage that just fine. Yes, you can get ones that do other things. This is what we're primarily using in EmComm work. If you have solar panels that are wired in parallel, the individual little cells, then they add their amps together. And that gets you a little bit higher amperage out, as long as they have the right voltage that they're all putting out. And this is really, really important. And it's something I learned from sailing. And so let's say we have our solar panel and we have this little bit of shade that we're going to throw on our panel. And we've got maybe our solar panels, when we got them, are wired in series, and when they're wired in series, the voltage increases, but the amperage stays the same as they're wired in series. If they're wired in parallel, the voltage would not change, but the amperage, you're getting more amperage out of those panels, depending on how they're wired up. So let's say you're going to partially shade one of these panels. We've got shade we can throw on all of these. Boom, we're going to, oops. Now I've got to go through my little animations again. There we go. There we go. Sorry about that. Clearly I'm pressing too hard on these keys. Goodness gracious, I should have made this animation go way faster. Come on, guys. And there we go. And one more. Boom. Now we've got our shaded panels. And notice we're only shading one cell. But if the one cell is that whole panel array that we have is wired in series, we're going to drop our amperage way down. We're not going to get as much power out of them. On a sailboat, if a line literally just one of the ropes on the boat, one of the lines lays over top of your solar panels, the older panels that I had. Your panels didn't produce any power, and now you don't have enough water to make ice to go in your rum drink. I mean, it's not a good thing. With the panels that are wired together in parallel, you lose some power being generated, but you don't lose as much. All right, so these panels that I have here, these are the monocrystalline panels. This is what I deployed. This is the Medic's vehicle. This is, we're back to Baker2Vegas here. So in full sun, cranking out 4 amps of power. Bob's your uncle. I can keep these things all topped up. Life is good. I come back a little while later, and the shade had fallen on the corner of the panel, and they went from producing 4 amps of power to producing less than 1 amp of power. I moved them another couple of inches, so they were back in full sun. Boom, right back to 4 amps. I mean, it was incredible to see just that little tiny bit of shade that got thrown on these panels, and it drops your power production incredibly. Now, why is that really important here in Southern California? Because we have fires, and when the fires are coming in, stuff gets shaded. You get ash that falls on them, and all of that just kind of shades out the panels, and they don't work as well. It's a real problem. These, on the other hand, these are the power film solar panels. Not only are they flexible, where you can fold them up, put them in your go bag, but these things are actually wired in parallel. So you can take and lay out the whole panel. It's producing about 4 amps. If you take and you fold one of those rows over, so you're actually cut the panel in half, essentially, you cut the power output in half. It goes down to 2 amps. If you take and you just shade just a little corner of one of those, you hardly notice the power drop that happens. It's a remarkable technology that they've done, and it's why they're so expensive. All right, here are those other foldable panels by Bioenno. These are, again, monocrystalline, but they fold up. If you have panels that are by the same manufacturer, and that's really important, you really want to make sure that you've got them by the same manufacturer, and they're the similar type of panels, and they're designed to work together, you can actually wire your panels together in series, so you can increase the amperage that you're getting out of them. So my 2 little 28-watt panels by themselves, each of them are producing like an amp, 1.8 amps or something like that. And when I wire them together, and these actually have little connectors, you can just barrel connect them together, it jumps right up to about 3.8 amps, and you get more power out of them. It's a really nice thing. All right, so here's our total solar power system that we've got. We've got our solar panels, we've got our battery, we've got our radio, and we have to have a solar charge controller. So what am I talking about, a solar charge controller? Solar charge controllers, they are always required, always. Don't plug panels directly onto a battery. Bad things will happen. What the solar charge controller is doing is, first of all, it's regulating the power generated by the solar panel, and it's managing the delivery of that power to your battery at a rate that your particular battery technology can use to charge with. A lot of words. It's doing all the math in order to make sure that your battery is getting charged properly. It prevents also power from flowing from the battery back into the solar panels. So your solar panels are not really smart devices. So if they've got sunlight, they're happy to take that sunlight, convert it into electrical energy, and ship it on down the line into your battery. But as soon as the sun goes away, it gets to be nighttime. A solar panel is just as happy to take that electricity out of your battery, flow it back into the panel, and just radiate it out as heat. And that's no bueno. So what you want to do is you want to make sure that your solar charge controller has a blocking diode in it, so the power can only go one direction. It goes into the battery and doesn't go back out into the solar panels and dissipate into the ether. With solar charge controllers for a ham radio operator, you want to make sure that your solar charge controller is RF quiet. I'm sure have heard of all the people like, I can't use solar panels because they make so much RF noise and this, that, or the other. No, they don't. If you have a properly shielded solar charge controller, you're not going to have all of that RF hash. And yes, you got to pay more money for that because They have standards, and they've got to go through and do all the wiring and map the stuff out. Now, if you go to, you know, your local neighborhood that has the solar roofs that are all set up in there because they're doing the right thing and they're making all that, yeah, there probably is a lot of hash going on there because they're not designed for RF quiet, and there could be some buzzing there. But you can get the same thing with any electronics that are out there that aren't properly shielded. So let's talk about the next thing. They handle the expected load of your radio on transmit. So I'll talk about some of these. So this is the one from Buddy Pole. You can see it's really tiny. And then this is the one from Bioenno. Love them both. They're both really nice panels. This one, however, the load port on it, where you can plug your power out of, this one can only handle about 15 amps of power draw, which is okay in a lot of respects. Many of your radios are going to draw less than 15 amps. However, if you're using a 100-watt HF radio, more than likely it's going to be drawing closer to 20 amps on transmit, especially if you're using a digital mode. No bueno, this doesn't work for that, but it is RF quiet. You can just plug the battery directly into your radio with that. This one, on the other hand, this can handle 30 amps out of when it's distributing the power out of the little power pole connectors over on the side. Talk more about that in a minute. You also want to make sure that your solar charge controller can handle the expected load coming in from your solar panels. Remember I said there's those big box stores, you can go get those cheap panels and get these big arrays of them. You can spend like, a couple $100 and you got this big giant array of solar panels. It's great for a home system. Yeah, but your solar charge controller also needs to be able to handle the voltage and the amperage coming in from those panels. So you want to pay attention to that. For the most part, for amateur radio work, a 60 to maybe 120 watt panel is about all you're ever going to need. Anything above that, you're talking about a larger installation of setting up for solar panels. So that's where those are going to work. Now, there's two types of these solar charge controllers. There's PWM and MPPT. And if you're into the alphabet soup, let's talk about that. So the first one, PWM, that's pulse width modulation. Now, what the heck is that? Pulse width modulation is cheaper. It's the easy way to go with it. It's cheaper. What it does is it switches a predetermined measured amount of average current directly into the battery on a cycle. So basically it works like a light switch. It just turns the light switch on and off, and it just distributes out a set amount of power each time, and it goes into the battery, and it's measuring that based on the settings that you have. So most of the solar charge controllers can do lead acid, they can do lithium iron, phosphate batteries, they can do gel cells, all of that. But there's a setting in them that you have to tell the solar charge controller what type of battery you're using. Don't use a lead acid battery charger with a lithium iron phosphate battery. Bad things will happen. MPPT, what the heck is that? Maximum power point tracking. What that means is it's more expensive. Why? Because there's more letters. Come on, this is easy stuff here. It's more expensive. It is highly efficient for a charger. And what it's really doing is it's got a computer inside, and it's intelligent. Well, I can't even say the word. It's intelligently managing the output of the panels with the voltage of the battery in order to maximize charging, and it does magical stuff, and your battery gets charged way more efficiently. It is ideal for long-term operation. So if you're going to be setting up and operating for a really long time, days, weeks, months, the apocalypse just happened, you're really going to want to have your MPPT solar charge controller, because you're going to get a little more power out of that thing. It's going to be a little more efficient. But we're talking about EmComm, so does it really matter? No, not really. Honestly, it doesn't, because most of our EmComm deployments, usually as a ham, we're going to set up and operate for a day, maybe 2 days, a few days. In the really big one, we might be set up for a little bit longer time. But as that time goes on, we'll have more people that'll come together with some additional kits that maybe we can increase some efficiency over time. But we're talking about efficiency that on the order of emergency communications is not going to make or break. So do you need to spend the extra money? If you've got it, great. Make sure you're getting an RF quiet one that's really good. Don't just go into Amazon and find the cheap solar charge controller, because you're going to be very unhappy when it starts making a lot of noise on your radio and you can't hear the other person talking. All right, so how do you connect one of these things up? So we've got our solar charge controller. You always want to start with the solar charge controller. That's your hub. That's where all the magic is going to happen. You start with that. That's the first thing you take out of your bag, by the way. You take out the solar charge controller. Then you take out the battery. You plug the battery into the solar charge controller, and magically, the solar charge controller boots up. It's got a little brain inside. Many of them have a little, either an LED or they've got a little display. It tells you, hey, life is good. I've not found one that actually has internal batteries in it so that it works without having a battery attached to it, which is actually a good thing because the whole purpose of this thing is to flow energy out of the solar panels and into the battery. So you don't want to be drawing an extra power or anything. You just battery into the solar charge control, step one. Next, you want to plug your solar panels in. Now, when you get on site, don't just open up your solar panels and leave them out sitting in the sun. The second those things hit the sunlight, they're creating electricity, which means you've got a live wire that's ready to plug into something somewhere. So make sure you're all set. You got your solar charge control, you plug it in, it's booted up. You can see the screens running. Fold the panels out, take the cord, plug it into your solar charge controller. Boom, you're charging. Your energy is flowing from the panels into the battery, ready to go. Third step, pretty simple, plug in your load. That's oftentimes your radio. A lot of these solar charge controllers have load ports on the solar charge controller. We already kind of talked about that. You want to use that load port if the load port is designed to handle the load of your radio. Otherwise, many of these batteries you'll see have two connectors on them. So you can plug the solar charge controller into one and plug the radio into the other. This is just a 50 amp power pole connector. And yeah, I've got an adapter for that too. It's kind of like using a Mac. You need a dongle for everything. It's just how it is. All right, so here's the solar charge controller. We just kind of talked about that. This one, when it shows up, it actually has these little ports on here. And I don't know about you, but I can't even read what those little icons are. So I read one time what they were. And it turns out the first icon is for the solar panels. And I know that because the sun is yellow. So I put a little piece of yellow tape on this connector so I know which one goes to the solar panels. The next one is for the battery, and I use Bioenno batteries. Their logo is green, so I put a piece of green tape on there so I could figure this out. Third one, that's the load port. That one I used is white. And you can see there's USB ports on these things. There's a little display on here, tells you what's going on, and buttons to push buttons, because buttons are fun to push, and you can make that all work. Okay, this is what the Buddy Pole Power Mini looks like. It's pre-wired with power pole ports right there on it, and they're clearly labeled. You've got a battery port, you've got your solar panel port, and you've got two load ports. It's not actually labeled, but over here there's actually a USB port as well. And you've got your little LED screen that's right here, a little LCD screen. All right, so what's on here? This tells you what is the system voltages. What's the voltage of the battery right now? What's the voltage coming out of the solar panel? So the panels that I've got plugged in here right now are generating 3.5 volts. Next line, it's telling you how many amps are going out or going into the battery. So on the battery side, this is how many amps are being drawn right now out of the battery. It's got a built-in meter, so it's measuring, it's telling you what's going on. This is how many amps are going in from the solar panel. So right now, 3.03 amps are going in. Then it tells you the net amp hours that have come in or gone out of the battery, and the net amp hours that are going into your battery, how much charge. There's also this little display here, and this is the maximum voltage that you set, the cutoff voltage that you set when you want the device to shut off, and that little teeny tiny line, that's like your fuel gauge. It's just falling down slowly, slowly, slowly over time. And it tells you, and it actually starts screaming at you. This one has a little alarm in it that says, hey, you're about to shut off your radio right now. End up that QSO. Let's move on. Make sure you get some more solar powers. Take a break from pressing the mic button. All right, so let's do a quick little review here. First thing you're going to plug in is your battery. Next thing you're going to plug in is your solar panel. And finally, you'll plug your radio into the load port. Now I just have a couple of pictures here that shows you a couple of little installations. So this is at Field Day 2019. We've got a mesh node set up at the Nike site on Mulholland. We've got our solar panel set out. It's really hard to see, but underneath of here is the battery and the solar charge controller. We come around over here, the power inverter. We've got a laptop that's being able to run off this. We're pulling the power off of that power inverter. And this little pole right here has a mesh node on it. We actually shot a mesh connection 22 kilometers across the San Fernando Valley in order to get onto the mesh and make some contacts on that. That was a lot of fun. This is winter field day at one of the local parks here. I've got my my antenna set up. I've got my solar panel set up. I just run that long extension cord just directly into here, and I've got my solar charge controller. We have our whole little like mini field day station set up running off of solar power. And really what it's doing is it's augmenting the power that we're drawing out of the battery. Here's another little portable setup I did. So if I'm up behind Mount Wilson here, I've got my panels, and underneath of the panels here, I got the solar charge controller. I've got my spare battery, so that's staying on charge. And then I keep my smaller panels up here that are connected up to my radio, and you know, they're being used and trickle charging this radio, so I could stay on the air for a really long time. This is a field day site. This is another one of the types of solar panels. It's also a monocrystalline panel. You can tell the little diamond pattern in there. These fold flat. This is, I think, about a 100-watt panel. They're a little bit bigger, but they're also super thin and light. And you can see we just literally just hung them up on the side of the tent, and they're generating power to help augment the power for our setup. This is at the marina. A lot of times I'll go up to the grassy area there, and I'll throw out my panels, and I'll set up my station and sit there and operate for a little while. So it's really nice because you bring your power with you kind of wherever you go. So let's go back to Baker2Vegas and let's wrap this thing up. So this is the night before the Baker2Vegas race. We're at the dispatch site. I just set the panels up. You can see the nice stands that they've got. There's room to be able to put the battery under there, put the solar charge controller, keep it out of the sun, keep those pieces nice and cool. And I was able to top up the battery. And this is the battery that I ended up deploying the next morning. And so I was really happy that I had really made sure that it was all fully topped up. So the next morning, we've got the medic station. They're on the air. We deployed the solar panels. They're trickle charging, keeping the battery topped up all day long. Life is just wonderful. And so I know the question that is burning in all of your minds, well, how long did it stay on the air and how much power did you use? Well, I'm thrilled to report that I had a little cheat in here earlier. So this was the answer to that. They were the setup that I deployed, that 30 amp hour battery that, remember, could only run that radio for 7 hours at a full out running it. Lasted the full night, 15 hours, no problem. And the next morning I took and I plugged when I got back to the hotel, I plugged the charger into the source side and I plugged the battery into the load side. So this little meter is showing you how much total power got put back into the battery. So at the end of the night, even though those solar panels were only producing a little bit of power all day long, the net loss out of those 30 amp hour battery was 5.206 amps. So it was able to keep up, and we could have kept operating for many more hours if we needed to. And with that, I'll just say thank you. I'll transmogrify myself back up. Maybe as a wrap up, we'll put the geochron in here behind me, and happy to take some questions if anyone has any questions that you have. So let me unpin myself and we can go from there.
When charging the iron phosphate batteries, do they require equalization like the LiPo batteries do?
Yeah, so what you don't see inside of these batteries, and not now, if you build your own, you have to figure out how you're going to manage this. But the ones that are commercially available, at least the ones that I've used, so this is the BioEnno battery. I would flip it up this way, but it looks really weird because it is green. You see right through me. There's nothing. If you look right in here, there is a what's called a BMS, a battery management system, that's built into the battery. It's down in the middle of the core of this battery. and it's wired to all of the individual cells, and that takes care of the balancing automatically for you. So for charging it, literally you just plug your charger into your power pole connector, and it magic happens and it charges. I don't know. Yeah. Yes, you do need to balance it, but if you get one of the commercially available ones, you don't need to worry about it because it does it for you.
Thank you.
Mm-hmm.
Again, one of the things that you learn sailing, and with respect to the battery duty cycle, lead acid batteries, they don't like being discharged to below 50%. So not only is your radio dying at the 50% level, if you're going below that with other loads other than your radios, the battery itself is getting sulfide building up on the plates, and it will never fully charge from that point on.
And anyone who drives a vehicle and has been like me and been a complete bonehead and left their lights on overnight or left the radio on. I mean, I know this has not happened to any of you guys, but for me, I'm such a bonehead that I've left the lights on from time to time, or the door ajar or something like that, and the battery drains and you're stuck the next day, and that battery is never the same, because then it takes a little bit less the next time before it doesn't charge up, and before you know it, you're heading down to Track Auto or wherever to pick up a new battery for your vehicle.
Something else that you didn't mention with respect to the battery duty cycle: lead acid batteries actually have a shelf life and a life besides the duty cycles,
Yes.
Charging and discharging. After about 3-4 years, they're not happy anymore, and they're not going to be operating their best, whereas the lithium ion phosphate batteries will last you 10 years plus.
Right. They also, the lithium iron phosphate, that's a really good point. The lead acid batteries, it's a chemical bath that's sitting in there. The acid loses some of its pizzazz over time. It kind of gets used up. They do deteriorate. Now, if you do have a lead acid battery or a gel or any of those other ones, and you leave them, you have them fully charged up, over time, they will drop that charge off just naturally on their own. So anybody who had that nice classic car sitting in their cousin's garage, because I can't afford one of those, but they've got a real nice classic car that they've got, and you come over and like, hey, let's go for a ride, and they forgot to leave the charger on it to trickle charge it, and the battery's just dead. Yeah, so that happens. That's not really the case with the lithium iron phosphates as much. They do decay a little bit, but remember that long flat discharge curve. So I operate on battery power 100% of the time, and have for about 3 years now. It's a lot quieter RF wise, so even my power sources are not quite as quiet as I find as what the batteries are for that, and even the nice ones that I've used. So other questions folks have?
There's one discharge that you didn't speak of the whole way through here that's very, very important. With the outfit that you had for Baker2Vegas that you're showing us, what was the cash discharge that was required to charge this system here?
I did mention that at the very beginning. I said I've reached out to a lot of different vendors in order to get some equipment to be able to teach with. Cash discharge wise, we're going to buy these commercially. I want to say the best thing to do is go to the manufacturer's website, so certainly don't quote me on these. I want to say these are about $250 or $300, I think, for the 30 amp hour. I find the 30 amp hour is kind of like that ideal sweet spot of being able to like portable around with it. This is what I have in my Go box that I have, and I do have that right here as well. This is literally just a plastic ammo can that I've converted into my Go box. At the top, I've got the little ports. So I've got power pole connector, 12-volt socket, USB. I've got separate power banks over here, so I can turn all of the 12-volt power on, or I can turn the radio that's inside of the boxes on its own separate switch. These are the ports for the radio itself, and then inside of the box, I can hopefully do this without throwing everything all over the place. I just custom wired the top of it, and then inside is the 30 amp hour Bioenno battery, the radio, the head unit, the microphone. Oftentimes I'll have my signal link inside of there if I'm doing digital kinds of things. We're teaching another WinLink course with the Aries LAX group. It will be starting in November on Sundays, and it'll be live on wavetalkers.com if you'd like to tune into there and learn how to do WinLink. But that's how I use that as well.
That's one of the three sources of cash draw on there. You've got a controller and the solar panel. If you had to commercially buy those two additional items, what are we talking?
Yeah. The solar panel. Okay, sorry. Your question was, I got sidetracked there. So solar panels vary in price. The solar panel wise, you're looking anywhere from $100, $200 up to those very nice power film solar panels that I have. Those run like $1,000. They are not cheap. But if you're going to if you're doing this where you're doing a lot of work that's out in the where you're having to carry stuff, that's definitely the panels that you want to save your pennies for. Generally the panels are a couple of $100. The solar charge controllers, the Buddy Pole one, I want to say they're about $200. The Bioenno one is a little cheaper. I think it's about $150 if I recall, for that.
Well, then to duplicate what you did, we're basically talking $1,500 in order to have the system there.
In order to have the whole system where you're using the power film solar, if you're using the more rigid panels, it's down closer to $500 or $600, something like that.
Because I think many of us are considering this with the idea of a decent system in the home. And if our power takes a dump here because the ground shook, we're talking days to weeks and not hours. So yeah,
absolutely. Yeah. So you want to have a system that's sized up. Now for your home system, having a couple of cheaper, larger panels ready to go is not a bad plan. I didn't talk very much about that because I'm talking about EmComm use where you're mostly going to be deploying somewhere. So in that kind of a situation, having something that's portable, if you're doing Aries work where you're reaching out to one of your shared agencies, you're going to the hospital to set up and operate, I've tried to design my system so everything pretty much fits in a backpack and I can walk from here to the nearest hospital that I would be assigned to and go and operate out of there. So that's definitely there. Now, going along with that, because of where we live in Southern California, we have power shutoffs, we have, fires that are going on, all of these other fun things that are going on. I found this system to be incredibly flexible. So I have somebody in my household that has a CPAP machine. And so when the power goes out, we need them to be able to breathe all night long. And so with the 30 amp hour battery, it kind of just gets them through the night. It's nice to have a little bit larger. So I have a much larger gel cell battery that's up in their space for them to use. But then I've got the solar panel so I can recharge that. And we do have a little bit larger array of solar panels to be able to make sure that's topped up. But there are many situations where we have lost power here. And I'll just, I've got the power. Because I operate off of battery power all the time, I don't charge off of commercial power either. So if I'm going to set up in the front yard to go operate for the day or whatever, I just throw the solar panels out and make sure I'm recharging the batteries as well. I will say if you're operating digital, if you like to play FT8, then your batteries are not going to last anywhere near as long because your duty cycle is way higher.
All righty. Remember, Randy, you can start small. You don't have to start off with the biggest solar panels, and you start off with a 15 amp lithium ion phosphate battery or a 20 amp, and you don't have to buy the 30 amp.
It's going to be 30. Come on, if you're going to do that, that part of it you're not going to cheese on.
Yeah,
you can't cheese. Even if you charge it off commercial power most of the time and ramp up with the solar panels later on, that one I'm not cheesing on.
Right. The bigger rigid panels that I have, those monocrystalline panels, I don't think they even sell the 60 watt ones anymore. I think they now do 100 watt panels for about the same. The price has been coming down on a lot of these as they've been going. Especially as a home installation, or if you're mostly traveling via vehicle, those are great because they produce a lot of power. Be mindful of the shading of them. Most solar panels on the market are all not shade tolerant. So it's definitely something to keep an eye on. The power film solars, that is something that is very special. And it's one of the things that actually increases a lot of the cost of those, is how they're actually manufactured.
All righty. Chris, is the classes that you're having on Wave Talkers, is that open to all amateurs?
It's open to all amateurs. We do have a sign up, so we only take so many in the live sessions. So we have a Zoom session, so you can join onto the Zoom session, and we only have so many slots that we take into there as kind of a first come first serve basis. We run them every so often, and then but we live stream them to the Wave Talkers website. So every Sunday. Not every Sunday, but when we're running the class, we usually run them on Sundays in the afternoon, usually around 2 o'clock or so. We live stream to the Wave Talkers website, we live stream to YouTube, and we live stream to the Facebook, the Wave Talkers Facebook page as well. So it's available, and then they're all up there. So if you wanted to go watch the previous courses, you can sign on to Wave Talkers and you can get access to the previous courses. They're also on our YouTube channel, and they're also on the Facebook page.
So that's on the wavetalkers.com website.
Yes.
All right. That's cool. Any last questions for Chris? Well, Chris, let me say thank you very much on behalf of the Santa Clarita Amateur Radio Club. And we appreciate your wealth of information and your presentation bedside manner is incredible. It's very easy to stay awake and and participate with your presentation.
It is not a dry drone. It is not a dry drone lecture. It's a lot of fun. I appreciate it.
Not like mine are.
Really appreciate it.
All right. So yes, thank you very much. We appreciate it. So anyways, thank you very